Hello friends, welcome back to the video series on quadratic equations and expressions. Okay. So we learned a bit, we revised a few important results about quadratic equations in the previous video. Now let's look at the questions. So the first question is, show that if the roots of the equation a squared plus b squared whole into x squared plus 2x into ac plus bd plus c squared plus d squared equal to 0 are real, then they will be equal. Okay. Now we know the condition for the roots to be real, right? The discriminant must be greater than or equal to 0. So it should be positive, right? So let's start with the discriminant. Discriminant which is given by t is equal to b squared minus 4ac, right? It's not the same ABC being used here. The b squared and b and ABC are actually from the equation ax squared plus bx plus c. So the b here is 2 times ac plus bd, this whole square, minus 4 times a, which is a squared plus b squared here, and c, which is c squared plus d squared. Right? So let's expand everything. Alright, and in this part, which is a squared c squared plus b squared d squared plus a squared d squared and b squared c squared. Okay, now since 4 is the common factor for both of them, let's see, a squared c squared here is with the positive sign, here it's with the minus negative sign. Similarly, b squared d squared, right? Now let's expand the square brackets, expand the brackets and simplify. So this is 4 into 2abcd minus a squared d squared plus b squared c squared, or this can be written as, let's take the negative sign outside. Oh, I'm sorry, here this should be negative, right? Watch out for these kind of mistakes. So don't write plus here, it should be negative, right? So take out the negative sign out and you have a squared d squared plus b squared c squared minus 2 times abcd, or that can be written as ad plus bc whole squared, right? If you again it should be negative here. It should be ad minus bc whole squared. You can write it either way, ad minus bc or bc minus ad. Doesn't make any difference here. Because when you square, you see it's a squared d squared plus b squared c squared minus 2 times abcd. Fine. So we see that our discriminant is minus 4 times ad minus bc whole squared. Whereas for the roots to be real, the discriminant should be greater than or equal to 0. Right? But we know that ad minus bc whole squared is always greater than, is always positive. Whereas minus 4 makes the whole thing negative. Right? Always positive into a negative will always make it negative. Hence, the equality should be the only constraint here. And in that case, AD must be equal to, or AD minus BC whole square should be equal to 0, or in any case, D is equal to 0. Right? And we know that when D is equal to 0, what do we have? Suppose the root is x. The root symbolically written, or okay, let's write it for this equation itself. It is minus 2 times minus b plus or minus b squared minus 4ac by 2a, right? So it is minus 2 times ac plus bd plus or minus root of d, where d is the discriminant, by 2 times the first term. So a squared plus b squared. But we have d equal to 0, right? Or in other terms, we get the root also. This is not asked in the question, but anyway, you see that since the discriminant becomes 0, we directly obtain that the roots must be equal. Okay, so hence we prove, proven that the roots are equal. Okay, let's move to the next question now. Okay, So the next question is, if alpha and beta roots of the equation ax squared plus bx plus c equal to 0, prove that a times alpha squared by beta plus beta squared by alpha plus b times alpha by beta plus beta by alpha is equal to b. Okay. Now, since we have been provided with the roots and the equation, let's write down the sum of the roots and the product of the roots. So, alpha plus beta, it should be equal to minus b by a, and similarly alpha beta is equal to c by a. These are the most important equations here. Now let's try expanding our LHS, the left hand side, right? Alpha squared by beta plus beta squared by alpha plus b times alpha by beta plus beta by alpha, right? So let's take the common denominator. This is alpha cube plus beta cube by alpha beta, and similarly this is alpha squared plus beta squared by alpha beta. Right, so we have the common denominator for both the terms here, and we have alpha cube plus beta cube plus b times alpha squared plus beta squared by alpha beta. Right, now let's try to write alpha cube plus beta cube in terms of alpha plus beta and alpha beta. So how do we do that? So we have here alpha cube plus beta cube is equal to, I write it this way. I first write alpha plus beta whole cube, right? Because we have the exponent 3 in both alpha and beta. Now if I expand alpha plus beta whole cube, I have alpha cube plus beta cube plus 3 times alpha beta into alpha plus beta, right? So I just subtract that part. Now if you see, you have alpha plus beta and alpha beta. These we are supposed to bring this into this form, right? So that we can now substitute our results for the sum of the roots and product of the roots, right? Similarly, I try writing alpha square plus beta square. So I first write it as squared, and when I expand this, I get alpha squared plus beta squared, but I have a plus 2 alpha beta, so I subtract that part. Okay. So now that we know the results for these things, let's put it in our LHS. So LHS was okay. Let's just okay. So LHS here will be alpha times. Now what is alpha cube plus beta cube? It is alpha plus beta whole cube minus 3 alpha beta, alpha plus beta plus, oh sorry, it's not alpha here, it's a here, right? A, and here it would be alpha plus beta whole squared minus 2 alpha beta, the whole thing by alpha beta. Okay. There was a mistake here too. It should be a here. Okay, so alpha plus beta is minus b by a and alpha beta is c by a. Fine. So let's go and substitute all this in our equation here. So I have alpha plus beta whole cube, that is minus b cube by a cube. Right? Similarly, minus 3c by a into minus, this is minus b by a. And now I have minus b by a whole squared minus 2 times c by a. This whole way alpha beta, I will try to keep alpha beta as late as possible and just substitute it in the end. Okay. So now let's expand the brackets here. So I have minus b cube by a cube into a, that makes this minus, minus b cube by a squared, and then I have plus, right, there is a minus and there are two negative signs here. So plus 3bc by a squared into a, or that makes it 3bc by a. In the next one it is minus b by a whole squared, which is b squared by a squared into b. So that makes it plus b cube by a squared. And then I have minus 2bc by a. Now let's substitute alpha beta. What is alpha beta? Alpha beta is c by a, right? Now the first term is minus b cube by a squared and the third term is minus b cube by a plus b cube. So they cancel. And now second and fourth terms, they too are similar but the coefficients are 3 and minus 2. So that becomes bc by a and that is divided by c by a. So we get b, right? We cancel c by a and we get b here, which is equal to our RHS. Right? So we see that in these kind of questions where you are given some relation of alpha beta and then probably some about the equation, some coefficients of equations are given, then you should start with writing down the sum of the roots and the product of the roots and try expanding your given result in terms of these things. Right? So let's move to the next question now. Okay, so the question is, find the value of p if 3x square minus 2x plus p equal to 0 and 6x square plus minus 17x plus 12 equal to 0 have a common root. Okay, so regarding common root, we had learned that let x itself be the common, let alpha be the common root. So we can write 3 alpha squared minus 2 alpha plus p equal to 0. Let that be our first equation. And 6 alpha squared minus 17 alpha plus 12 equal to 0. And that is our second equation. Right. Okay. Now let's eliminate alpha squared. How do I eliminate alpha squared here? I multiply the first equation. With 2. Right. So I have 6 alpha squared minus 4 alpha plus 2p equal to 0. And now I subtract the second equation from this. So I get minus 4 alpha plus 2p, the minus of minus 17 alpha plus 12. I need not write alpha squared because I know I am eliminating it. So I get alpha is equal to so I have minus 12 here, 12 minus 2p by 13, right? Now let's eliminate alpha here. So the second equation, now I have minus 2 here and minus 17 here, right? So I multiply the first with 17 and I multiply the second, this is the first one. I multiply the first with 17 and the second one with 2. So what do I have here? I have 51 alpha squared minus 34 alpha plus 17p equal to 0. I also have 12 alpha squared minus 34 alpha plus 24 equal to 0. Right? So let's subtract one equation from the other, and I have 39 alpha squared plus 17p minus 24 equal to 0. And that gives me alpha squared is equal to 24 minus 17p by 39, right? So this is my, let's write, this is the third equation, this is the fourth equation, right? So I have the equation for alpha and I have the equation for alpha squared. So the only logical thing now is to square the equation of alpha and equate it to the one for alpha squared. So I get 12 minus 2p by 13 whole squared and that is equal to 24 minus 17p by 39. Right? So let's expand everything. I have 144 plus 4p squared minus 12 into 2, that's 24 into 2, that's 48p, that by 169. I have 24 minus 17p by 39. Okay. So now 39, this is 13 times and this is 3 times, right? Okay, so now I cross multiply and I get, let's bring everything to one side. So I have 3 into 4, that is 12p squared, 3 into 48, that is 144p, 3 into 144, and that will be 432, minus 24 into 13, 13 is 260, plus 13 into 452, that is 312, and 13 into 17, that is 221. So I added this side, right? So I have 12p squared. I have 221 minus 144p, that is 77, and I have 432 minus 312, that is 120, right? So now I have a quadratic equation in P. So I can just solve it for P and I'll get my values of P, right? So P now is minus 77 plus or minus, what is 77 squared? Okay, so 77 squared is 5929 minus 4 times 120 into 12. The whole thing divided by 24. Right? So this gives me 77 plus or minus, the discriminant is found to be 169, the root of which is 13. And so I have minus 77 minus 13 gives me minus 90 by 24. Now minus 90 by 24, and the next one is minus 77 plus 13 or minus 64 by 24, right? So let's divide, let's write them in the smallest, in the simplest form, and this is divided by 6 gives me 4 and 15, and this divided by 8 gives me 8 and 3. So the values of P are minus 15 by 4 or minus 8 by, right? That's what I was asked in the question, right? Find the value of P. So you see, if you remember that I had mentioned in the theory that there is a result for these kind of questions. Remember that is actually a bit tough, or otherwise you can just quickly do this way. You can eliminate both alpha and alpha squared and then obtain the relations and then just do the next step, and you will get something, and then you should get back to what the question asks. So here the question asks of P and we get the values as minus 15 by 4 and minus 8 by 3. Right? The next question here. So if the equations ax squared plus bx plus c equal to 0 and x squared plus 2x plus 4 equal to 0 have a common root, then find a is to b is to c. The question asks the ratio of a, b and c. Right? Okay. Again, we start with the same thing. Okay, so let's eliminate, okay, let's write down the same way. This is my 1. This is my second equation. So, I multiply the second equation with a, that gives me ax squared plus 2ax plus 4a equal to 0, and now I subtract this equation from the first one. Ax squared is gone. I have b minus 2ax plus c minus 4a equal to 0, where x is equal to 4a minus c by b minus 2a, right? Similarly, I now multiply the second equation with b by 2. Fine. What does that give me? So I have b by 2 x squared. Now 2 times b by 2 gives me b, so bx, and 4 times b by 2 gives me 2b. Again I subtract this from the first equation, and I have a minus b by 2 squared, x squared, x is removed, and I have c minus 2b. That gives me x squared is equal to 2b minus c, a minus b by 2, which can be written as 2a minus b by 2. So this becomes actually 2 times of this by 2a minus b, right? So from these two boxes I just square the first one. So I have 4a minus c whole squared by b minus 2a whole squared, giving me 4b minus c by 2a minus b. Now I see that there is a different sign here, right? 2a minus b, and I have b minus 2a. So when I cancel them, I put a negative sign on either of the sides. Doesn't matter which side, but you should put a negative sign, right? Now I cross multiply. Okay, so I have 4a minus c whole squared. That gives me, on expanding, 16a squared plus c squared minus 8ac. And now on the negative side I have, on the right hand side I have 4b minus c into b minus 2a. Right, so that is 4b minus c into b minus 2a, or 4b squared minus bc minus 8ab plus 2ac. Right, now I bring all of them to one side, and I have 16a squared plus 4b squared plus c squared minus 8ac, and just a second. I'm so sorry. This should be 4b minus 2c, right? This is 4b minus 2c. 2 is multiplied to both of them, right? So it's 4b minus 2c. Okay, so 4b minus 2c. Let's again write this part. So this should be equal to 4b into b, that's 4b squared, minus 2c into b gives me minus 2bc, 4b into minus 2a gives me minus 8ab, and minus 2c into 2a gives me 4ac. Fine. So this is the thing. And now, bringing it to one side, I have 4b squared minus 2bc and minus 8ab. Right? So I have 16a squared plus 4b squared. Oh, I'm so sorry, I've written b squared again twice. Okay, so let's try to factorize the equation we have got here. Right? So I have 16a squared plus 4b squared plus c squared minus 4ac minus 2bc minus 8ab equal to 0. Fine. So this is something, okay. So I have 16a squared plus c squared minus 4ac. Okay, I'll try to do it this way. 4a minus c whole squared, that gives me 16a squared minus plus c squared minus 8ac. So I have one extra 4ac, right? Because there is just minus 4ac here. So the other part is, I write this way now, minus 4b into 2c into 2a minus b. Right? Let's see if all the terms are accounted for. 4b into minus b, that gives me 4b squared, yes. 4b into 2a, that gives me 8ab minus 8b, yes. 2c into minus 2c minus b, that's 2bc minus 2c, yes. And then an extra 4ac, right? So minus 2ac, yes. Fine. So now when is this? Now in this kind of equation, since this is always 0, we should have this as an identity, right? So that means 4a minus c is equal to 0, and at the same time 4b minus 2c is equal to 0. What does this give us? 4a equal to c, or a by c is equal to 1 by 4. Similarly, 4b minus 2c equal to 0 gives us 4b is equal to 2c, or b by c is equal to 2 by 4. And last, 2a minus b is equal to 0 gives us 2a is equal to b, or a by b is equal to half. Combining all of them, what do we get? We get a is to b is to c is nothing but 1 by 4 is to 2 by 4 is to 1, right? Or taking it as numerals, we get a is to b is to c is equal to 1 is to 2 is to 4. Fine. So the question asks for the ratio of a, b and c for the equations to have a common root, and we find that to be 1 is to 2 is to 4. Alright. Now for the fifth question, if alpha beta are roots of the equation x squared minus px plus q equal to 0, and alpha 1 beta 1 are roots of the equation x squared minus qx plus p equal to 0, form the quadratic equation with roots 1 by alpha 1 beta plus 1 by alpha beta 1 and 1 by alpha 1 plus 1 by beta 1. Right. Again, for these kind of questions, now here it's slightly different, right? First of all, you have something with about the roots, but then you have to form the quadratic equation. So let's see how to tackle this kind of question. Now first of all, you have, since the roots are given and the equation is also given, let's write down the sum of the roots and product of the roots for both the cases. So I have alpha plus beta is equal to, from the first equation I have that equal to p, and I have alpha beta equal to q. For the second equation I have alpha 1 plus beta 1 is equal to q, whereas alpha 1 beta 1 is equal to p, right? So they are just opposite, so we say the 5. Now let's try to write the sum of the roots of the desired equation. So that is, suppose that is s. Now what is this? This is 1 by alpha 1 beta plus 1 by alpha beta 1. This is thus the first root. Then the second one is 1 by alpha 1 plus 1 by beta 1. Right? So let's take the common denominator, and we have alpha beta 1 plus alpha 1 beta, that is by alpha 1 beta 1. Here also we'll have the same thing, so we can just add everything in the numerator, and I have alpha 1 plus beta 1 by alpha 1 beta 1. Now this can further be written as, let's take, say, from the first and third I take alpha common, so I have alpha 1 plus beta 1. Similarly from the second and fourth I take beta 1 common, and I have, this is alpha 1 beta here in the second. It's just beta. So I take beta common, I have again alpha 1 plus beta 1. So this is nothing but alpha 1 plus beta 1 into alpha plus beta, right? And I have that by alpha 1 beta 1, right? So what is this? The sum of the roots of the desired equation is, what is alpha plus beta? Alpha plus beta is p, and alpha 1 plus beta 1 is q. And what is alpha beta? Q, and alpha 1 beta 1 p. So this is nothing but qp by pq is equal to 1. So we get that the sum of the roots is equal to 1. Similarly, let's find out the product. Product is 1 by alpha 1 and beta 1. The second root is 1 by alpha 1 beta, 1 by alpha beta 1. Right? So I have alpha 1 beta plus alpha beta 1 by alpha 1 beta 1 whole squared, right? So I have, I'll write that as alpha 1 beta 1 whole squared. Let's try to expand the numerator here, and let's factorize that. So I have alpha 1 squared alpha beta, then I have So alpha beta plus alpha squared alpha 1 beta 1 plus beta squared alpha 1 beta 1 plus beta 1 squared alpha beta, right? This divided by alpha 1 beta 1 whole squared. Now here again I cleverly try to take the common things here. So alpha beta is common, and for the first and fourth, and I have alpha 1 squared plus beta 1 squared. That can be written as alpha 1 plus beta 1 whole squared minus 2 alpha 1 beta 1, right? I write that as alpha 1 plus beta 1 whole squared minus 2 alpha 1 beta 1. Similarly, in the second and third, I have alpha 1 beta 1 common, and I write that as alpha 1 squared plus beta squared as the same thing, alpha plus beta whole squared minus 2 alpha beta, right? The whole thing divided by alpha 1 beta 1 whole squared. Excuse me. Okay. So let's try to okay. So here we have alpha plus beta equal to P, alpha beta equal to Q, and alpha 1 plus beta 1 equal to P, and alpha 1 beta 1 equal to P. Q and P. Right? So let's substitute these things. Okay, so we'll have to be extra careful here. Okay. So second. So alpha beta was P, and alpha plus beta is equal to Q, and alpha plus beta is equal to P. I'll just write that here. Is equal to Q, and alpha beta is equal to P, right? Oh, sorry. Alpha beta is equal to Q. Sorry. So this should be just one is enough, because the other one is the other two. So alpha plus beta is equal to P, whereas alpha beta is equal to Q. Right? So alpha beta here, let's put it in this above expression here. So alpha beta Q, right, with alpha 1 plus beta 1, now that is also Q, so Q square minus 2 alpha 1 beta 1. Alpha 1 beta 1 is P. Now alpha 1 beta 1 is P, and I have alpha plus beta, it is P squared minus 2 alpha beta is Q. Right? Now what is alpha? Alpha beta is Q, alpha 1 beta 1 is P. This is P squared Q squared. Right? Okay, so let's try to simplify the expression here. I have Q cube minus 2PQ plus P cube minus 2PQ by P squared Q squared. Or this is P cube plus Q cube minus 4P cube by P square Q square. So I see that the sum of the roots was 1, right? The sum of the roots was 1, whereas the product of the roots is P cube plus Q cube minus 4P cube by P squared Q squared. Now whenever I write an equation as it's not A square, ax square plus bx plus c equal to 0, the sum is minus b by a, whereas product is c by a, right? So since I have, so I'll write this in terms of my, let's write this as c by a, and since the product, the sum is, it says minus b by a, right? So since it looks like as if the sum is just 1, but what we will do is multiply the sum here with the same thing as P here, as A here. What is A? A is P squared Q squared. So I get B as minus P squared Q squared. Hence my quadratic equation here is A I write as P squared Q squared. Whatever B is, it should be the negative of that, so that the sum is just 1. Right? So it's minus P squared Q squared into X, and then my C is P cube plus Q cube minus 4P. Right? So this is my quadratic equation. Okay, so we see in this question that from the given conditions we find out we always write the equation for sum of the roots and product of the roots of the given equation, and hence try to find out some relation between the given condition and what's desired in the question. With that, and finally with a little manipulation, we obtain the final answer. That's it for this video. In the next video, we'll cover a few more questions and wrap this chapter.